Morning, everybody, and you're very welcome to this morning's Institute of Food and Health Research Bites. And this morning it's going to be delivered by Professor Frank Monahan. So Frank started out his academic career in UCD with a BSc in biochemistry, and then moved to UCC to do his PhD, and then went onwards to UC Davis, where he did a postdoc before being appointed to an academic post here at UCD. So Frank has held a lot of important roles, making an awful lot of contributions to UCD over the years, the most recent being as head of the Food Science and Nutrition section, a post that he held from 2011 to 2019. And most recently, he's been doing an excellent job in his appointment as Associate Dean for EDI within the School of Agriculture and Food Science. So Frank has made huge amount of contribution, not only to the scientific field, but also to the UCD community. And in recognition of that, he was recently given a Values in Action Award from UCD, which was very well deserved. Excuse me. So we'll pass over to Frank now. So he's going to talk to us this morning, I think, about nutritional quality, sensory attributes, and authenticity of meat. Over to you, Frank.
Many thanks, Dolores, and thanks everybody for tuning in this morning. So as Dolores said, this is the title of what I'm going to talk about, trying to link, I suppose, the food science through to some nutrition as well. So Geraldine sent me this brief a couple of weeks ago, so I'm going to try and in the next 15 or 20 minutes touch on many of these things, the research problems that our work addresses, the challenges, and who benefits, who the beneficiaries are, and how we engage with them, what the impact is, the timeframes you work to collaborators, and how it's funded. So hopefully you'll get a sense of that in the next 20 minutes or so. And I am conscious that many of you probably don't know what work, exactly the sort of work that I do. So I'm looking forward to telling you about it. So I suppose way back, and Dolores will remember this from days in UCC, my work was on dietary factors affecting lipid oxidation in pork. So this was around feeding pigs different diets at the time in Moore Park and looking at the effect on quality. And it was feeding vitamin E and fatty acids, looking at different fat sources. And when I look at what I'm doing now, those same sort of themes are still there. Project on Ethiopian beef, again around fatty acids and the effect of animal production systems on them. The Smart Sward project here is around, it's a study out at Lyons Farm looking at botanically diverse swards and effect on meat quality. A project in Northern Ireland, again very much around animal production system through to meat quality. And up here in the top right, a project where we're looking at vitamin E again and looking at ways of making like natural vitamin E with the School of Chemistry. So very much some of the same themes still there. And then moving into the authenticity space, looking at grass-fed beef and if it has a signature. So I'm going to talk a little bit about that as well. And other projects that have recently finished looking at lamb meat production and the effect of gender on lamb quality. A study looking at right through to human nutrition and the impact of beef consumption, beef with particular composition on human nutrition or indicators of human nutrition, and also then looking at processed meats and making them healthier. And on the authenticity part, so as well as looking at beef, we're also doing some work on milk. Currently through FHI, and again that milk interest goes way back. We did a little bit of work on whey proteins and gels and emulsions and edible films. So what I'm going to do is just touch on a few of these topics and hopefully give you a flavor of what the sort of work that we've been doing. So I often describe my work using a slide like this. So, looking at animal production systems through to meat quality, but also looking at it in reverse. What can we tell from meat about animal production? So in this case, it might be the level of grass feeding. But not only that, from meat, what information can we get about its geographical origin? Where does it come from? And so that's what the authenticity is about. And in terms of dietary background, it might be grass feeding, or it could be country of origin. As I said, that can equally well be applied to milk and dairy products, which is what we're doing. So I want to talk initially about this project here, which looked at impacts on lamb flavor. And the basic question we were trying to answer was, is the flavor of lamb affected by castration of lambs? Is there a ram effect? Because any of you who eat or consume lamb may know, this is a very distinctive flavor, but there is the perception that male lamb from males, particularly from rams, has an off flavor. So to do this, we trained a descriptive panel. One of our PhD students, Vasiliki Garane, did this. And any of you who are familiar with sensory analysis will be familiar with this training protocol. So the panel have to agree some common descriptors that they'll all evaluate the lamb on. And I suppose from a lamb perspective, what's interesting is the types of descriptors people use for lamb. So some are ones you might expect, like roast beef, roast lamb, lamb gravy, but others you mightn't, like farm smell, grassy, rancid, greasy, fatty, dirty straw smell, manure. So these are all aromas that people detect when they look at lamb. And so for this study, the descriptive panel came up with this final group of aroma, flavor, parameters to look at, and texture and aftertaste. So again, you can see some pleasant ones like roast meat, but also some of the others like woolly, rancid, manure, fecal, and so on, that are not so pleasant. And our descriptive panel then looked at lamb from rams and castrates, and this is just a summary of some of the data we got. We looked at 2 breeds, Texel crosses and Scottish Blackface, which are mountain lambs, and looked at some of these undesirable attributes. And if you just eyeball the figures, you can see that for the rams, the figures tend to be higher than for the castrates. So the descriptive panel is picking up more of these undesirable attributes in the rams and castrates. And when you look at, one or more undesirable attribute, 34% of rams had one or more undesirable flavor or aroma attribute, compared to 17% for the castrates across the 2 breeds. So the descriptive panel are definitely telling us there's something there. When we went on then to look at a consumer panel, this is of about 100 people, and asked them to look at and taste the lamb on using a hedonic scale, again, you can see that in terms of overall liking, slightly higher for castrate lamb than ram lamb, for flavor liking the same, and for tenderness liking the same. So small differences, but significant. But I suppose importantly here, the value 5 is for neither like nor dislike. So what we concluded from this is that consumers don't dislike either, but they like the castrate lamb a bit more than the ram lamb. So there does seem to be a ram effect, but whether or not it's enough to make, we don't think it's enough to make people dislike the lamb. I want to just move on then to look at another project relating to beef and grass feeding. And this was a nice study where we connected right through from animal production through to human nutrition work with Breege and Helen and Nugent, and with Chagas as well, where we looked at substituting cereal concentrate fed beef with grass-fed beef in the Irish population as using the NANS database, the National Adult Nutrition Survey, and the beef that the participants in that consume. So substituting, looking at if they consume concentrate fed beef versus grass-fed beef. And just as a little bit of a backdrop to this, in terms of the diets that animals consume, they differ in their fatty acids. And if we just look at these two on the right, particularly the omega-3 fatty acid, alpha-linolenic acid, is much higher in grass or silage than in concentrate, which is in blue here. So the green is grass, the blue concentrate. And similarly, the reverse is true for linoleic acid, lower in grass and silage, higher in cereal concentrates. And then when you follow that through to look at the meat, and I just want to look at these fatty acids here on the right, and they're blown up a little bit here. Again, you can see in grass-fed beef, higher C18-3, omega-3 fatty acids, lower in concentrate fed, the same for conjugated linoleic acid. And then importantly, the omega-6 to omega-3 ratio goes down in moving from cereal feeding to grass feeding. So, we have a lot of data on this. And a study was done in Northern Ireland back in 2011, looking at, well, does this translate into humans if you look at habitual red meat consumers, and if they were to substitute their grass-fed beef with, the concentrate-fed beef with grass-fed beef, would it make any difference? And you can see that the green here is for grass-fed beef in the omega-3 fatty acids, EPA, DPA, DHA, all long-chain PUFA, and total omega-3 PUFA. You can see that the grass-fed beef is higher than the platelet omega-3 fatty acids from those who consume the grass-fed beef is higher. And then this was the really interesting bit that we did with the more recent work, looking at the NANS database. And so the population was, if you like, marked against their total fat. The recommendation would be that total fat should contribute less than 33% of total energy, saturated fat less than 10%, MUFA greater than or equal to 12%, PUFA greater than or equal to 6%, and so on. So these are from the dietary guidelines, EFSA guidelines, and UK guidelines. And what you can see is that for monounsaturates, polyunsaturates, ALA, and trans, there was the population met the guidelines. But in terms of total fat being less than 30% of total energy, more of the population met that, or were closer to it, 98.5%, if they consumed grass-fed beef versus concentrate-fed beef, which was 95%. So significant difference there. And in terms of saturated fat, 57% would meet that guideline of less than 10% of total energy coming from saturated fat if they consume the grass-fed beef, compared to 51%. So in addition to the effects on individual fatty acids, for example, alpha-linolenic acid uptake, we could see these effects of substituting grass-fed beef for concentrate-fed beef using the NANS database. So again, moving on a little bit then to look at that, animal science, animal production, meat production through to human nutrition. This was some work we did looking at alpha tocopherol, again, vitamin E in beef, and stereoisomeric forms of it as an indicator of supplementation. And that followed through to some work with, again, the NANS database and blood samples that were taken as part of that work, and looking at the alpha tocopherol in the blood samples. So just as a little bit of a background to this is alpha tocopherol, one of the forms of vitamin E. And it has 8 different stereoisomeric forms, which arise because of the arrangement of the methyl group around these 3 chiral carbons. So the naturally dominant one is the RRR isomer. So that has a particular orientation of these 3 chiral carbons. But there are 8 other stereoisomeric forms. These 4, using the methodology we have, come out as one peak on our HPLC, but the others we can distinguish. So if you look at pasture or silage, as you'd expect, predominantly the RRR, naturally occurring stereoisomer. But when you look at a cereal concentrate, like a barley-based concentrate that's often fed to cattle, it'll be supplemented with synthetic vitamin E in the vitamin-mineral mix. And in synthetic vitamin E, you get all stereoisomers. So we were able to show, when you analyze the beef, that this is the beef is containing predominantly the RRR isomer when the animals are fed pasture, but it follows through to the meat. If they are fed concentrates, you find all stereoisomers. And if you feed some concentrates with pasture, you'll still pick up some of the stereoisomers. So this was work we did back in 2011, and then later looked at the NANS cohort. And again, as consumers, we consume alpha tocopherol in natural form from the foods we consume, particularly plant sources and oils. But we also, if we take supplements, consume the mix of stereoisomers. And supplements can be either natural or synthetic. So the natural will have the RRR, the synthetic, the others. And from that study, which was again a nice collaboration with Breed and Lorraine and Eileen and Mike and Yang, who was a PhD student at the time, we looked at vitamin E from food sources, but then from people who were consumers. Some didn't consume supplements, but others did at low levels, high levels of synthetic supplements, or high levels of natural supplements. And what was interesting about this is when we looked at the plasma of these different groupings, the non-supplement users and the supplement users, we see different profiles for the stereoisomers. So on the left here, we have the non-supplement users. So these people are getting their alpha tocopherol from food sources. And on the extreme right, food sources plus natural supplements. And you can see the profile isn't all that different. The RRR isomer is dominating. Because it's a natural source. But what's interesting is when you look at consumers of synthetic supplements, the profile of the alpha tocopherol in the blood plasma changes, and the RRR is being displaced by the other stereoisomeric forms. Of course, the RRR is more bioactive. So it's just interesting when you take supplements that you are actually changing the profile of the tocopherol in your blood, and the follow through would maybe to look at this then from a human health perspective and other markers of cardiovascular health or and so on. And that study, I suppose, is I suppose connected to this one currently, where with the School of Chemistry and Declan Gilheany and Oregon State University, looking at seeing can we produce nature identical RRR in the lab, and that would be a big bonus in terms of if it can be done economically in terms of providing the RRR for animal feedstuffs. So instead of the synthetic one, so you get the more bioactive form directly into the animal studies. And it's an early stage, but we do hope to go to human intervention studies with that, and Eileen would lead that. And I should say here, it's a collaboration with Devonish Nutrition, so we're going to do it in chickens, some of the work initially with chickens. So moving on then, just before finishing up to authenticity, briefly, this is some work looking at European lamb and using stable isotopes, hydrogen on the y-axis, carbon on the x-axis, and looking at lamb from across various parts of Europe. Out here in the extreme left, we've the Orkney Islands, and this is Irish lamb that we took from the Burn. So one of the messages from this is you can see the advantage of an island status. Our samples cluster nicely together. Of course, it's not always that simple. This is one of our samples from the Burn, which didn't cluster with the others, and that's just indicating that farmer fed a different diet, probably more maize, which affects the carbon quite dramatically. But more recently, we've started looking at milk and grass-fed milk, and there's a lot of discussion around the extent of grass feeding. Kerry Gold were queried on this. Milk from grass-fed cows, and people are asking, well, what does it actually mean? And we just published this paper this year, looking at it's a description of the Irish milk pool, and you can see blue here indicates highly grain-fed milk, green highly grass-fed. So using stable isotopes, we can see different profiles in the milk. And the advantage of stable isotopes is that it's very difficult to change them or to fake it, if you like. And so this is just for carbon. We've done it for other elements as well. And the multi-element approach is good. The differences are greater in February than at other times of the year, because the animals are coming out of the winter period where the intensity of feeding concentrates is greater. And then finally, and not unrelated to this, is a project we're working on, the signature of grass-fed beef. So again, it's one that's funded by the Department of Agriculture, Food and the Marine, looking at grass-fed. And again, that question, how grass-fed is it? And interestingly, since this was funded, the government just late last year, the Department of Agriculture, put in a proposal to Europe for PGI status for Irish grass-fed beef. And in that proposal, our work is cited in terms of fatty acids and so on in grass-fed beef, and two of the PhD students featured here, Porrick French, former PhD students, and Sibikiso. And it's all based around this grass-fed standard that's guaranteeing that the beef that meets this Irish grass-fed beef would have 90% of the animal feed coming from grass or forage sources. So the project, I suppose, was interesting in that this is exactly what it sets up to do. Can we detect differences in beef, commercially produced beef, that we could use to underpin this claim that it is grass-fed? So I've alluded to some of the funding sources already. Work a lot with Chagas, you can see. And just in terms of that reach out to industry, Beef Sig, we're getting a lot of help from KeyPack, and obviously through FHI and the milk dairy products as an automatic connection to industry. And Meat Technology Ireland are kept briefed on the research as well. So I hope I've given you a sense of the various things that Geraldine asked me to cover in going through the sharing the data that we have. And thank you for listening.